All right. So from our everyday experiences, we notice that things heat up differently. For example, if you leave a piece of metal in the sun and a cup of water, the metal gets hotter faster. Right. So not everything gets hot at the same rate as other things. So, for example, again, if you had like a block of iron, let's just say 1 gram of iron, and then you had 1 gram of water, and they're going to be both at 25 degrees Celsius. And then we're going to add some energy to them. Let's say we add about 8 joules of energy into these systems. The metal block will get quite toasty and it'll go up to about 41 degrees Celsius, while your drop of water won't experience nearly as much of a change. It'll only be about 27 degrees Celsius. Even though we've added the same amount of energy, the temperature hasn't changed by the same amount. And so this is what's known as specific heat capacity. It gets a capital C as the symbol, and it's defined as the energy required to increase the temperature of 1 gram of material by 1 degree Celsius. And this comes from a property of the material. So every material has its own specific heat capacity. And then here's just a table of specific heat capacities. You can see at the top is water. Water has a relatively high specific heat capacity, whereas these metals generally have significantly lower specific heat capacity. So again, it gets the symbol C. It has, or it's equal to the amount of heat added and then divided by the mass and the change in temperature, right? Where Q is heat, M is mass, usually in grams, heat, of course, in joules. And then your delta T is your change in temperature, which is usually in degrees Celsius. It can also be in Kelvin, so capital K. We'll learn about that a little bit later. For this kind of stuff, it's interchangeable. So degrees Celsius and Kelvin aren't always interchangeable. When it comes to specific heat capacity, they are interchangeable. So again, it's the amount of heat required to increase the temperature by 1 degree Celsius of 1 gram of the material. And so specific heat capacity has units of joules per gram degree Celsius, right? All of that makes sense. And again, if you look at the table, water generally has a very high specific heat, while metals generally have very low specific heats, which explains why metals get hotter faster than water.